Hi, welcome to Elonix. In this episode, we'll see how to make an LDR based light sensor circuit while simultaneously learning how it works. We'll also see how to convert this into a darkness sensing circuit. So let's get started. For circuit diagram or any other information, please refer to the description. These are LDRs, short form for light dependent resistors or photoresistors. As the name signifies, the LDR's resistance depends on the intensity or brightness of light incident on it, and the relation is of inverse proportionality. That is, if the brightness of light increases, the value of LDR's resistance reduces. We can use this property to make a basic light sensor circuit by connecting the LDR in series with the LED and the other terminals connected to a DC power source. Right now, the brightness of light is very high. So because of inverse proportionality, the resistance of LDR is very less, resulting in more current flowing through the circuit and the LED glows much brighter. Now when I slowly reduce the brightness of light, the LDR's resistance gradually starts increasing, and so the current through the circuit slowly reduces, and so the LED's brightness reduces. This is a basic light sensor circuit you can start with, but it has some limitations like you can't control at what brightness of light the LED turns on or off. Also, practically we would want the LED to turn on when it is dark and turn off when there is enough light. This circuit can't drive heavy loads too. So for these reasons, we'll make a more functional circuit using transistors. The first thing we need to do is convert change in resistance of the LDR to change in voltage. That can be achieved by adding a resistor in series with the LDR, that's a 1 kilo ohm resistor, and connect the other terminal of the LDR to positive rail and the resistor's other terminal to the negative rail. Right now, same amount of current flows through the LDR and resistor because both of them are in series. When the brightness of light increases, the resistance of LDR reduces, and when the resistance of LDR reduces, there will be lesser voltage drop or difference from this point towards the positive side. So the voltage at this point increases. We can now use this increase in voltage with respect to brightness to turn on LED or any other load using a transistor. I'll be using an NPN transistor BC547. If you intend to use any other NPN transistor, check the pin configuration from its datasheet. Now, for an NPN transistor, the base is of P junction, and more positive bias or voltage at the base will turn on the transistor. So, connect base of the transistor, which is at pin 2, to common point between LDR and resistor. Emitter, which is at pin 3, is of N junction and has to be in forward bias. So connect pin 3 to negative rail. The collector is to be connected to the load. So connect pin 1 to negative terminal of the LED, and positive of the LED is connected to positive rail via a 470 ohm resistor. Turn on the power supply, anything up to 12 volts, and here you go, the light sensor circuit. The sensitivity of this light sensor depends on the series resistance to the LDR. At 1 kilo ohm, the sensitivity is low. That is, the LED turns on only above medium level of brightness. If you replace it with 10 kilo ohms, it turns on LED even if there is little light. So if you wish to have adjustable sensitivity, you can replace the series resistance with any two adjacent leads of a 10 kilo ohm potentiometer. For making a dark sensor circuit, you need to replace the 1 kilo ohm resistor with LDR and the LDR with a 47 to 100 kilo ohm resistor. You can also use a 100 kilo ohm potentiometer for adjustable sensitivity. The working of this circuit is almost similar to the previous one, except that the voltage at the base increases when brightness of light decreases. You can try finding out the reason why we have used a 10 kilo ohm potentiometer for light sensor circuit and a 100 kilo ohm potentiometer for darkness sensing circuit. Thanks for your time. Do subscribe and have fun.